Hello, you're welcome back to our online class. In the last class, we discussed direct variation. So today we are going to be looking at inverse variation. If you have not watched that video, you do well to go and do that. It is there I did introduction to variation, and then we discussed and solved some questions on direct variation. Today we are going to look at inverse variation. What do we mean by inverse variation? You already told us that variation is simply the relationship between two or more variables, how one quantity affects another. In inverse variation, we are simply looking at how the increase in one quantity leads to the decrease of another, or the decrease in one quantity leads to an increase in another. And it can also be said that two quantities are inversely related if their product is a constant. I repeat, inverse variation is a relationship between two quantities where the increase in one quantity leads to the decrease of the other. Or you can say that two quantities are inversely related if their product is a constant. Okay, so and it is represented that if we say that A varies inversely as B, we can simply say that A is proportional to 1 over B. This is how that is represented. And of course, you know that I said always that when we remove the proportionality sign and introduce an equality sign, we introduce a constant K times 1 over B. Of course, this is A equals K whole over B. And by the second definition, we said that two quantities are inversely related. A is inversely related to B if their product A times B is a constant. That is, whatever A is and whatever B is, whatever change that happens in B that causes a change in A, or vice versa, their product will still be the same. So as A increases, B will decrease in a proportion such that their products will remain what it is. If A, for example, is 5 and B is 10, their product is 50. If A increases to 10, B will decrease to 5 so that their product will still be 50. If A increases to 25, B will decrease to 2 so that their product will still be 50. If A increases to 50, B will decrease to 1 so that their product will still be 50. That is what we mean by inverse proportion. So as one is increasing, the other is increasing. That is what inverse variation is all about. Let us look at a few questions so that we'll see how we tackle it. So if we look at this question that says x is proportional to 1 over y and x is 7 whole number 1 over 2 when y is 4, find A, equation connecting them, B, x when y is 12. So solution first. So look at it now. This is our relationship. X is proportional to 1 over y. And I said we change this to equality sign so that x is equal to k over y. Okay? Then you substitute. If we substitute, this is 7.5, x is 7.5, y is x is 7.5, and I said you can't use mixed fraction, so you change it to improper fraction. 7 times 2, 14, plus 1, we have 15 all over 2, and then our y is 4 when x is 7 over 7.5. So you substitute 15 over 2 and 4 into this equation because this is the equation connecting them. So when we substitute that, we have 15 over 2 as x equals k all over y is 4, and we have this. So we can now solve for k. We cross multiply here, k times 2, we have what? 2k. 4 times 15, we have 60. You divide both sides by 2 so that k is 60 over 2, and that makes a k to be 30. So you put it back in this equation. Remember what we did in direct variation. Put it back in the equation so that x equals 30 over y. This is the answer to number A. This is the answer to number A. So this is the equation connecting them. You can leave it this way. You can cross multiply so that it will be xy equals 30. Still the same equation connecting them. Then B said we should find x when y is 12. Find x when y is 12. How do we do that? Okay, in this equation, I said once I've gotten the equation connecting them, any other question that comes will be solved using the equation connecting them. So what do? We substitute here or here. So x is equal to 30 over y, and our y this time around is 12, and that will give us what? 2.5. We have 2.5, so x is 2.5 when y is 12, and that is it. Okay, looking at this other question, given that n varies inversely as d cube, what are we going to do? Solution. N is proportional to d cube, but inversely. So inversely, you say 1 over d cube. That is what it is. If it is inversely, you say 1 all over, or you multiply them, equate it to a constant. Okay, if it is direct, it would have been n proportional to d cube, but inverse proportion is n proportional to 1 over d cube. Okay, when n is 240, d is 3. We use this to solve and get our key. So I said you change this to an equality sign and introduce a constant all over d cube. Okay, then you substitute. N is 240 equals to k all over d cube. D is 3, so you have 3 cube. So we have 240 equals k all over 3 raised to power 3 is 27. Okay, so it means that our k, when we cross multiply this, is over 1. If you cross multiply this, k times 1 is k, and 240 times 27, you have 240 times 27. That is your k. Okay, so the equation connecting them is to substitute this k here. Okay, of course you can point this and get what it is, but it's not relevant to me because that's not what I'm looking for. I'm looking for n when d is 2, so I can carry this k and substitute equation connecting the variables, so that I will have n equals 240 times 27, that is k, all over d cube. Okay, then he said I should find n when d is 2, so it is in d I will substitute 2, so that my n equals 240 times 27 all over 2 raised to power 3. So n equals 240 times 27 all over 2 raised to power 3 is 8, and then when you compute this, you get 810 as your n, and that is the answer. Thank you.